So hello everyone, welcome back to my YouTube channel. So today we'll be starting with artificial intelligence and machine learning, in which we'll be covering Python codes for all of the searching techniques like BFS, DFS, UCS. We'll be seeing all of them, and also we'll be seeing a memorizing trick by which we can write the codes for all of them. So let's start. So first of all, let's understand a basic search problem structure. Almost all algorithms use a state, initial state and a goal state. This is your goal. This is your initial. I is equal to 0 to goal. And there will always be a function associated. Like in A star we have Fn is equal to Gn plus Hn. This is the total cost in reaching that node, and this is the heuristic value of the node. Heuristic value of node. Cost is optional. The cost means from I is equal to 0 to goal. Suppose 4 is the weight or the cost associated, and heuristic value for uninformed search. Now we usually represent a graph in this format. Tuple is equal to neighbor and its cost. So this is the basic format. Now we'll start first of all with uninformed search. Uninformed search means no heuristic value. Uninformed means we do not know how the path is going to go. Along with traveling the path, we'll see which is the best path for us to reach the optimal solution. So let's start with BFS, breadth first search. So breadth first search uses a queue and it finds the shortest path in an unweighted graph. Now, in case of BFS, there is a guarantee of an optimal solution. And in DFS, we'll discuss it in DFS, but in DFS we get the path, but it may or may not be the optimal path. But in BFS, we are guaranteed an optimal path. So now let's see the template first. So template says from collections, import DQ. Now there will be a graph, there will be a start node and an end node. That remains common. Q is equal to DQ of start. Start is in the queue. I'll give an example also. So suppose A, B, C, D, E, F, G. Now visited is equal to make it a set. Set is unique values. While you're iterating through the queue, you pop a value from the left. Then node is equal to path of -1. If your node is equal to the goal, then you return the path simply. If next after that, if you get a node that is not visited, then you visit it. And then you check the neighbors. If the neighbors you are checking, you simultaneously put it into the new path and you append that value in the queue. So this is basically, now let's understand with the help of example. I know this may not be clear at the moment. So suppose we first traverse the start node, that is A. After that, we pop it and we see its neighbors B and C. Now you pop from the left. Simple. Now, when you pop from the left, you have C. Now, the neighbors of B are D and E. Then you pop left, then you get D, E. Neighbors of C are F and G. No neighbor for D, pop E, no neighbor for E, so no addition. Pop F and you reach the goal node. So this is how it works. You use a DQ, uses pop left, no cost associated and no heuristic value associated. Remember, I'll write it here, remember. So this was about breadth first search. Now let's see depth first search. In depth first search, it may or may not give optimal solution. It uses a stack, it goes deep first. It goes deep means I'll show. Suppose it starts here and then it goes to B, then it goes back to A and then C, like this. A thread. If you may have studied threaded tree, this concept will be clear. So we'll not discuss the threaded tree part, that's a different concept altogether. So now let's see the template first. DFS graph start goal. In the stack, add the start visited set. You pop from the stack, then you check for the path. If it is not visited, you visit and you append it into the stack. Almost the same. I just had to repeat what I did in BFS. Now you'll understand just the differences queue and stack. Replace queue with list. Pop left with pop. That's it. Now I'll explain with the help of an example. A, B, C, D, E, F, and G. A is your starting node, so let's put A into the stack. Pop this A. Now you have B and C. Pop B, but now earlier the neighbors were going to the right. Now it will be B is getting popped, so D, E, C. D gets popped. So you have no neighbor, leave it. E gets popped, no neighbor, leave it. Now C gets popped. C has neighbors F and G. F gets popped, no neighbor, and you reach the goal node. So this is how DFS works. Go deep. Next, let's see UCS, Uniform Cost Search. Uses priority queue and it expands the lowest cost node. Now, if we see the full form Uniform Cost Search, this guarantees the lowest cost path. Cost path. Import heap queue. Now, PQ is your cost. Now it has a cost associated. Cost associated. So we'll add cost and start visited set pop check for if node is equal to goal, return the path and cost. If not, you visit it, append it. The same concept, just a code will be a little bit different because weight will be associated. I hope this would be clear. Heap queue is the library. What change? Heap queue keeps tracks of cost and you take the smallest cost first. Cost plus weight. And your new is pushed into the stack. I hope UCS will be clear. Now let's see an example. I think this is for those who could not understand this concept. Let's suppose we have two, here we have one. Now let's say A is really greedy person. He doesn't want to spend anything, neither he doesn't want to give anything. He just wants his profit in life. So if A wants to reach the market, this is market 1 and this is market 2. Now he wants to go to the market and get some grocery. So he wants to go in a auto. Now one person is taking 2 rupees and one person is taking 1 rupees. What do you think? Which one will you prefer? The 1 rupee one? This is a basic example. This is just for your explanation. So AC will be the path that he will cover. He will get the groceries, one for going and plus one for coming back home, 2 rupees. While if he'll go in 2 rupees, then he'll have to spend 4 rupees, double the cost. And why will he spend double the cost when he can go to the market at 1 rupee? So this is the basic concept. Next we have iterative deepening search. This is not so important from the exam point of view, but we'll cover it because it will be there in your syllabus. DFS with depth limit repeats DFS increasing depth. Here depth will be associated. If you will see, it is there in the parameter also. Function parameter. Depth is for function, those who don't know. If depth is 0 and your node, that is the first node, is your goal itself, you return the path. If your depth is greater than 0, now in neighbor, now when you don't want a second argument, you do underscore. So you use recursion here, recursion. You return your result. Then in IDS function, this is your main function. You can use recursion till the maximum depth, 0 to max underscore depth. And you return the result if there is a result. What changes? You add the depth limit, it is recursive and it repeats DFS. Very important. I'll erase this part. Yes, it may be not visible. This will be not so important. Just read. I'll read only. Next, informed search. Informed search uses heuristic value. Now let's understand what do you mean by heuristic value. Let's suppose we have a person A, a person B. Now, suppose A wants to go to B's home and B's home is at a distance of 24. Suppose it takes 24 rupees to reach his home. Let's take a simple thing. Now, B has a appointment price. Now, if A wants to meet B, he has to pay a price. Let's suppose B charges 2000 rupees. That means A will first spend on the auto ride plus he will also spend for meeting B. He has to give a party. That's important. So 2024. This is the total heuristic value that A has to incur. So this is the basic concept. This is the simplest explanation that I can give. He wants to go in an auto to his home. Then he wants to give him a prize. That is a party, let's say. Let's say he wants to give a party. Now first he'll have to go there, then he'll have to pay for the party. Simple. So GN is your path cost and HN is your party cost, that is heuristic value. How much he charges to meet? Heuristic value. Now import heap Q 0 plus heuristic of start 0 comma start visited set he f comma g comma path. Now here also you had three arguments in PQ. Node is, then we'll return path if node is equal to goal. If not, we'll visit it and push it into the heap queue. Same always. Adds heuristic and the concept I will explain. Fn is equal to g of n plus h of n. It's mentioned here. Next, hill climbing. Hill climbing is basically greedy. Moves only to the best neighbor. No backtracking. Current is equal to start, path is equal to current. If current is not equal to goal, neighbor is equal to graph of current. Then next node will be your. Now, what is this part? Let's understand this. This is known as a lambda function. The syntax is lambda. This is your input part, and heuristics is suppose the function, and you have to use this input here in the argument. This is really important. This is how a lambda function is formed. Let's suppose we have a function x of input. This is just an example. If heuristic value is greater than your current, return none. Current is equal to next node and you append the current path. It chooses the minimum heuristic, stops at a local maximum. So this is easy compared to the previous ones in terms of the code. So now let's go on to the next one. IDA star and AO star. Iterative deep. So let's write iterative deepening A star algorithm. It is a combination of iterative deepening search and your A star. It uses F cost threshold. Now threshold, the concept I have written, set threshold is equal to H of start, do DFS with F limit, increase the threshold. Exam answer usually requires algorithm steps and not the full code. This is for your theory exam only. Exam only. Now, AO star. AO star is really important in terms of theory exam. Now, let's see first what is AO star. Let's suppose Raj has two friends, Susie and John. Now, Susie has two friends, A and B. John also has C and D. Susie says that if I meet Raj, then A and B will also meet Raj. Now you can't just take A with, now suppose if Susie takes only A, then not possible. You have to take both of them together. Susie plus A plus B. You have to take A and B. If there is a sign like this, and this is an AND sign, you have to take A and B. This, when there's no sign, is OR. I'll erase this because this is an AND sign. So this is the meaning of the full form is AND OR. Admissible. A star stands for admissible. Used for AND or graphs, more complex, used in problem reduction. Algorithm steps are asked, diagram is asked, and not full coding actually. In A star. A star is really important. Mark my words. A star program is very important. BFS, DFS is really, really important. How to write an exam? If a question says write a BFS algorithm, first write initialize a queue. Then mark start as visited. Now, while the queue is not empty, you remove the node. Then, if goal is equal to node, you return. Add unvisited neighbors, if any. Then write the code template simply. This is the basic structure. Now, this is a revision table for whatever we have done today. BFS, DFS, UCS, A star, what uses cost, what uses heuristic, what is data structure associated. This is very important. If you understand this part clearly, then code template will be very easy for you all. Learn, So I'll not be covering because I've already explained whatever is there in this slide. So now let's move to the next slide. Now, very important exam trick. If you forget everything, just remember BFS uses queue, DFS stack, UCS uses a priority queue because there's a cost associated. A star uses priority queue. Cost also, heuristic also. Hill climbing chooses the best neighbor only. That alone can fetch 60 to 70% marks because these four, the upper four, this one also. This is very important. Instead of memorizing the code, memorize, search Google loop, frontier, goal test, expand. If you remember that, you can reconstruct everything. I want you to do one thing. Don't read, just read it once and close the video. I want you to close the video from your phone and write this down. If you are able to write this part, that means your BFS, DFS, UCS are all clear and dot dot dot. This is a 25-line universal search template. If you all face any difficulty in writing the code, if you want to memorize. Now, I will not be in the favor of memorizing the code. If you understand the concept pretty well, you will be able to write the code, at least the template. This is a template that includes all of the BFS, DFS, UCS, greedy, A star, and all. You read this. This is simple and explains everything step by step. If you have any doubt, you can ask me in the comment section. So let's move forward. Now, how to remember it? Very easy trick. You remove a node, you check the goal, and you expand the neighbor. Only priority changes. First, you remove the node. You check if the removed node is goal. Suppose A is the goal itself, then you return it. Otherwise, you check B, C, and so on. Expand the neighbors. This part, if you see, this is for your 25-line template. This is not something related to the topic we have done today. This is if you want to use BFS, you will use BFS as a parameter. Now BFS uses Q, DFS stack, UCS cost. This is important. Learn it by heart. So that is all for today's video. I covered all of the Python codes with you all. If you like the video, do like, share, and subscribe to my channel. And if you want my notes, you can see in the short section, I have been uploading notes of all the subjects that I have covered till now. There are some topics which I have not covered in the video section, but I have posted the notes. That is for your self-study. If you want to see them, you can surely see them. So thank you all. Bye bye. If you have any doubts, do mention it down below in the comment section. Bye bye.